even after 20 years of deploying Rails applications, I was still personally caught out while trying to do this by a couple of things that didn't work the way that I expected.
Our next speaker, André, you might know him from Bundler, Ruby Gems, or the Ruby Way, and maybe in the last 2 weeks in my newsletter or other newsletters, you might have read about this new kind of Ruby management tool called RV. But today he will talk about a subject that I think is super interesting, and that is about Rails on SQLite, exciting ways to cause outages. I experienced one myself, but not exactly an outage. I experienced one when I paid a lot of money because I misconfigured Livestream with some database. But still, I'm very curious to find out what André will say. A big round of applause, and let's hear him.
So, yep, great, cool. Okay, so between LightStack and the Rails 8 trifecta of solid cable, solid cache, solid queue, it is easier than it's ever been before to set up a new Rails app that just doesn't need a database service, doesn't need a Redis service, doesn't need a file storage service maybe. And it's really great to simplify things. I'm a fan. But even after 20 years of deploying Rails applications, I was still personally caught out while trying to do this by a couple of things that didn't work the way that I expected. And so kind of like based on what happened when I built this side project using SQLite as the main database, I'm going to talk about what's different, what's new, and several ways that you can completely knock your site offline or delete your production database that you maybe didn't expect going in. And we'll talk about the advantages of SQLite and how it makes some things easier, faster, cheaper, better. So before we do that, who am I? How did I learn these things? Why should you listen to me? My internet handle that you maybe know me better by is indirect. On all the internet things, I helped create Bundler 1 million years ago. And I've been on the open source team for Ruby Gems and for Bundler for many, many years at this point. I work at Spinel Cooperative, which is a collective of Ruby open source maintainers. And we maybe, based on these last 2 talks, I've been a little bit inspired to say that we sell core team expertise as a service. And so if you're interested in talking to somebody who's been on Bundler core or Rails core or Stimulus core, we have experts who are available as a service. And then the other thing that we do is we build RV, as was just mentioned. And we have some, we're really excited about making new tooling that's different and better than tooling has ever been before. But for this particular application, for this particular talk, the application that is the most relevant is this small side project that I built for my own personal use originally called Feed Your Email. So Feed Your Email, as you might imagine from its name, turns your newsletter subscriptions into RSS feeds, right? I have spent many, many years reading newsletters in RSS, and nowadays there are enough newsletters that are just emails and don't have RSS feeds anymore that I got very annoyed by my inbox being full of newsletters. And so I built this service so that I could get all of the things I wanted to read into my feed reader and keep all of the things that I needed to reply to in my email inbox. So the way Feed Your Email works is you push a button and it gives you an email address. The system doesn't even have accounts. You just push a button, you get an email address. Every email that goes to that address goes into an RSS feed with the same URL. And Feed Your Email is really only possible because of SQLite. If I had to maintain, 3 Postgres instances and a couple of web instances and a background worker instance, and it would have been too much hassle. I wouldn't have built this side project that was entirely just to solve my own personal problem of I want my emails in an RSS feed if I also had to then be a whole DevOps person and a whole, maintenance person. This doesn't make any money. It's just convenience for me. And so SQLite really helped make that possible. And so in the end, this feels kind of like a casual for fun project, but that works well enough thanks to how it's designed and deployed that I can also just make it public and anyone can use it. And there's enough resources that people who want to use it, as long as I rate limit them a little bit, it works out fine for everybody to be able to use it as a public service. So the app serves about 1 million requests a month right now. And that number sounds kind of big, but if you do the actual math, that's like 24 requests a minute. So, from the app's perspective, it needs to serve a request like maybe every 2 seconds, 2.5 seconds, something like that. And that's like, sure, 1 million requests a month is a lot, but like any Rails app can serve 1 request every 2.5 seconds. Like it's not a big deal, right? You don't need some huge hulking server to handle 1 million requests a month. You need like 1 VM, basically. So I run this on Fly.io as like, a single VM, and it costs me like, I don't know, maybe $14 a month or something like that. It also has some additional bonus features. There's a web view where you can like share emails as a link to someone that you want to like talk to about some, it's like an email that you've gotten. So it's also kind of accidentally like share your inbox as a link as a service. It also has full text search for everything that you've ever gotten on a given address. It like has completely indexed all of the text inside all of the emails, and you can like find, if I have a couple of feeds that at this point have like many years worth of history. And so I'm able to like go and, find an old email by searching through the text, which is great. The full text search is also a feature of SQLite, which brings us back to the actual topic of this talk. So how did SQLite help make this possible? And the biggest fundamental difference, like where kind of like all of the other differences fall out of this as a side effect, is that SQLite runs inside your web server process. There is no database server, so to speak, right? Like there's no process, there's just a file on the disk. There's no, I guess like to really belabor that point, there's no port, there's no socket, there's no process. Your web server has the SQLite library, like, as a function it can call, and that function reads something off disk or writes something to disk, and that's it. This is totally awesome, by the way. You can't have database connection errors anymore, right? Like if you can write to the file system, you have access to the database, and there's no, oh, we had a network problem in the data center and your app went down because it couldn't reach the database. It's just a file. Having things be just a file is very cool. In addition to it being very cool, it means that if you make something that is a SQLite database and you deploy it to Heroku, which maybe you're used to doing, as we heard in the last talk, well, there's a problem that you should know about in advance, and it is that your production database, after you've deployed your SQLite Rails app to Heroku, will be completely deleted every 24 hours. Heroku ensures that no individual web process can ever live beyond 24 hours, both as kind of like a security measure, so you don't end up with like long-term Bitcoin mining, whatever, but also as kind of like a defense against memory leaks, against like problems. And so the thing is, if your production database is just a file, and it's just a file inside your web dyno on Heroku, it gets thrown away when the dyno restarts every 24 hours. And so you should definitely do something about that. So that's the first thing you should do. You should persist your production database and not just like write it into your Heroku dyno. So this is the most important rule of doing anything in Rails with SQLite, is you need to put the database file in some kind of persistent storage. On AWS, that means like you need to create like an EBS volume or something like that. On Fly.io, they just call the thing volumes. Very straightforward. But like whatever platform you're running on, you need to make sure that you have some kind of like persisted, backed up, like storage that as you start new containers or deploy new versions of your app, that you'll get the same file every time. Ideally, wherever you're storing your file will also have snapshots, which is really helpful, right? Like something horrible happens to your database. If you have a snapshot, you can like go get a copy of your database from yesterday. And file system snapshots are so much easier and less complicated to have, to manage, to back up, to restore than, Postgres replication, et cetera, et cetera, et cetera, right? Like it's just a file. This is great. It's super helpful. So now that your database isn't going to disappear because you've figured out how to persist it, we can talk about the other cool things that fall out of your database being available as just a file. Like maybe you use rails.cache to store things, temporary data. Well, that's just a file, a SQLite file now, right? Maybe you use ActiveJob, send emails, run background tasks. Well, that's also just a file now. And how do I put it? So putting everything in one file makes things extremely easy. But I am actually, well, the advantage of putting everything in one file is that you just back up that one file and now you're done, right? Like if something goes horribly wrong, you bring back that file, your cache, your jobs, your database, all your models, like everything's now back, which is pretty great. However, and this is kind of like the trade-off that we're really getting at, because SQLite is inside your web process, what happens if your web process and your background worker both need to interact with the database at the same time, right? Like somebody's resetting their password at the same time as your background worker is trying to like update a model entry in the database. So this is also a problem, right? Like maybe you are used to deploying your workers as like a separate dyno or a separate container or a separate, whatever, you run them somewhere else so that you can like scale them up and down separately from your web workers, which you scale up and down based on traffic, not based on how many jobs you need to run. And the problem is that that doesn't work anymore because your entire database and your queue, all of it is in a file, and you can't like give that file to completely different containers simultaneously, right? Like EBS doesn't support being mounted in multiple containers because that would be a total nightmare. And so instead, you have to change the approach that you take to how to make all of this work. Since your database is now just one file, you either have to run your workers in another process inside the same container, all located in the same place, right? So maybe you're like trying to figure out how to squeeze in an additional, job worker process or a sidekick process or whatever into your dyno or your container. Or if it's a smallish app, and this is even at 1 million requests a month, I would call this a smallish app. You can just set up the job worker to be threads inside your Puma process. Like, it's actually really nice. ActiveJob has the thing where you can just say like, oh, this is just async. Like, spin up a thread, run the background job, and then it's fine. Like, if your background jobs are running in threads, you actually don't even have to pay the memory cost of booting up an entire additional Rails process to have a worker. Like, as long as you have enough CPU in your one VM to serve both web processes and background processes at the same time, like, you can even just, you only have to pay for a VM that can run Rails once, which is pretty great. So if you really like end up with, a bigger app, and, it's kind of like Rails is full of examples of really successful applications that don't actually have, kind of like global giant amounts of traffic. But if you do end up with larger amounts of traffic, what you need to do is like have planned in advance to scale completely vertically instead of scaling horizontally, which is like the easiest way that people are used to doing it based on traditional Rails architecture, right? You can't add additional VMs because your database is just one file, and you can't have 5 VMs all, competing over the same single file. But you can add a bigger server that has more CPU and RAM. Maybe you can add additional, Ruby processes inside that bigger server. Maybe you just have 1 mega giga Ruby process. I don't know. Depends on how your app works. But you can get, like nowadays, you can get a server that has 128 cores in it and that has several terabytes of RAM. And so, like, personally, I am not actually very worried about this. Like, I am unlikely to build something that's going to scale like Shopify as a side project. And so, like, I'm just not going to think about it, really, is what it comes down to. Like, servers are good enough. And then the catch becomes, and this is kind of like an additional trade-off, if you have dozens or hundreds of processes or threads all trying to talk to the same database file, there's probably going to be a lot of contention. And this is novel, right? Like, we're used to having many Puma workers or, background job workers, and they're all in flight simultaneously, right? Like many different processes can all talk to a database over a socket at the same time. And like Postgres and MySQL are architected so that you can have many completely different kind of like views of the database when transactions are in flight, right? Until they commit, like worker 1 is seeing its own changes and Puma 1 is seeing its own changes, but the database is smart enough to like reflect self-consistent views of each of those things as they're happening. SQLite doesn't have any of that. It's just a file. And if you have a Puma worker and a background job worker and they both try to do something to the database at the same time, they just have to wait in line for each other because you can't, read a file or write to a file from two different processes simultaneously. And so the way that SQLite handles this is file system locks. And so if you actually have hundreds of things that are all trying to read and write to your SQLite database file simultaneously, maybe you're going to start getting noticeable latency because they all have to wait in line for each other and none of them can run simultaneously. And like by default, the way that SQLite solves this problem is it requires a full database file system level lock to execute any read queries. And so every individual read for every individual, web request or individual worker, like all you want to do is like find out, look up the user row from the user ID. And now you have to like get in line to get a lock to be the sole process that owns the file. And that can be a problem. So the solution that SQLite offers to that particular problem is write-ahead logs. And so the way that works is it makes it possible to remove the lock and the contention for readers, because as long as you know for sure that the file isn't going to be updated while you're trying to read from it, there's no like possibility of corruption there. It means that all of the readers can work simultaneously without needing the fancy locks. And then all of the writes go into an append-only log that gets kind of like synchronized into the database to be read in blocks. But what that means is that you have like kind of like periodic write locks, but you don't have like continuous ongoing locks for every single thing that you ever want to do, which is a really big improvement, right? And so that does solve the contention problem, but it kind of like solves it by removing one of the things that I was just telling you is what's so great about SQLite. By adding a write-ahead log, that means that there's actually now more files. It's no longer just one file on disk. And so now you're like worrying about like, well, this whole directory that has, however many files in it. And you definitely want to make sure that you keep a copy of the write-ahead log, because if your process crashes, it's possible that some writes will have been put in the log, but won't actually have been fully synced into the database yet. And so if you want to not lose data due to crashes, you need to make sure that you have kind of like a live, copy of whatever the write-ahead log is. And I have some suggestions about that I'll get to in a minute. And then the other approach that's worth calling out here is that you can also strategize splitting up your SQLite database into several SQLite databases that are all organized around like a specific use or a specific access pattern. And so maybe you like break out your cache because that's mostly read heavy, and you separate it from like your active record model data. Maybe you also add another separate SQLite database for your background job, like queue entries. Because each of those systems has like a different access pattern. And so it means that you can try to optimize for those problems individually. And it also solves the problem of like, oh, I need to bulk and queue several thousand background jobs. And now I have created contention that means that the next web request has to wait for all of those thousands of background jobs to enqueue before it can, write whatever that update that the user timestamp logged in or whatever thing is that you need to write. So if you create a separate SQL file per system, per access pattern, you can also create a separate SQLite database for action cable. And finally, and maybe most controversially, you can maybe even use SQLite as a blob store for active storage instead of like an S3 bucket. And if you already have to deal with, like this persistent file system, and you already have a strategy for backing up this set of SQLite files, like maybe that actually is a great simplification, and you don't need to worry about configuring an AWS IAM. You don't need a separate AWS account from whatever it is that you're actually hosting. You don't need to worry about maybe this is secretly public and people can download it. You don't need to worry about how do I give someone a signed URL that they can use to upload to my file store. Like everything is just inside a SQLite file, and like your blobs problem is also solved, which, yeah, may be worth it. Taking this approach to the absolute extreme, this is the most, I have heard of one place that has sharded per user so that every account gets its own SQLite database to hold all of the active record models that are associated with that account. And this is like maybe a little bit deranged, but it also has like some really kind of like nice side effects where you can be like, oh, do you want to export your data? Like, here, have a copy of your data. You can be like, oh, is there contention? Well, like, I can guarantee you that the contention is only you personally trying to work with your own data. And so now that we've covered kind of like vertically scaling the Rails server, I just want to talk a little bit about the implications of the application working on that like one server, right? Like if you are limited to one server, the downside is that if that one server goes down, now your entire app is down, right? You don't have the ability to have like several Puma workers and they can like take turns. Like you only have one app. So that especially if you're running in a container, you basically can't deploy without downtime anymore, right? Like if you build a container, the shared persisted files, like you have to completely shut down the container running the old version of your application before you can like move the persisted attached storage to the new container and then like boot that new container. So this might be a reason to be like maybe more interested in running your Rails app on a VM where it's like processes and you can like partially, like if you have a load balancer on the VM, you can like do deploying by shutting down some of the Puma workers running the old code, start up new Puma workers running the new code, and you can kind of like stagger it. And honestly, like welcome to how we used to have to do everything in the 2000s, and I'm sorry. Another thing that's maybe more of an advantage is that if there's only one server, it's much faster to try and figure things out. Like there's only one place you need to look to figure out what's going on with Puma. There's only one place you need to look to figure out what's going on with your background worker. There's only one place you need to look to figure out what's going on with your database. You don't have to like trace, you don't need a distributed logging system to trace the transaction across 17 different machines because there's just the one machine. Like you can go into that machine and figure it out. Another thing that's like maybe an advantage is that like load balancing is intrinsically much more straightforward if there is only one server that you ever need to worry about, right? You have one IP address, the server has the IP address, the load balancer knows how to talk to it. I mean, and there is kind of like eventually a scale where there only being one server and there only being one network stack and there only being one IP address does actually become limiting to your application. But like the good news is, you probably won't ever have an app popular enough for that to become a problem. And if you do have an app that is that popular, like then, you should get experts at doing that to like help you figure it out and it'll be fine. But the other thing that's really great that's like helpful about working with SQLite, if you're ever interested in switching to or switching from SQLite, the SQL gem is actually amazing. It turns out that the SQL gem can speak the like individual protocols of Postgres and MySQL and SQLite, and you can like tell it to wire any database into any other database. And so like I actually, during this Feed Your Email project, I migrated in and out of Postgres as I was trying to figure out what made the most sense. And it was actually just like super straightforward. Like I was able to just say like, here's the address of my Postgres. I would like a SQLite file here with the same data in it. And then I like told Rails to look at the SQLite file, and everything just worked. It was fantastic. The final limitation that kind of falls out of you only having one server is that your app can only run in one geographic location, right? Like if you have the kind of app where it matters, if you are close to your individual users, maybe this is not actually a good fit for you in that case, right? You can only run it in one place. You can at least use the kind of like CDN locality that is common if you're using a Rails app on a cloud platform. At least the static stuff can be closer to your users. But this kind of like simplified architecture that makes things easier is not able to support the kind of like extremely fancy multi-region, multi-replication kind of setups that you hear people talk about at conferences. So before we wrap up, I'm getting to the end, but I want to make sure that we cover the ways that you can back up this file. And the absolute star of SQLite backup is called Lightstream. And it has, there's a packaged version of Lightstream that's a gem. It's super great. You can just put the Lightstream gem in your bundle and you can run your Rails server using like Lightstream exec. And it's great. That's actually all you need. It intercepts all of the traffic to the SQLite database and to the write-ahead log, and it makes sure that as things get added to the write-ahead log, they are also written into an S3 bucket. And that means that if your entire application just like ceases to exist, a truck hits the data center, that happened to me once, and the server is just gone. Well, the good news is that the entire write-ahead log up to the minute that the truck hit your server is in S3, and you can just like pull the files out of S3 and tell SQLite, here's the write-ahead log, please make sure that this database is fully up to date. It's really good. On AWS, this means that you also need to like set the right environment variables so that Lightstream knows how to access the bucket. But if you're using like Fly.io or other services that have kind of like a better S3 alike is maybe the right word, kind of like an S3 API compatible setup. So like on Fly.io, they have a thing called Tigris, and you can just say like, please give me a bucket. And then all the environment variables get set for you and you never have to think about it again. It's really great. The very last thing that you can try if you're feeling extremely adventurous is called LightFS. And I love this project just because of how like completely deranged it is. What they have done is they have written a custom file system that you put your SQLite 3 file into that understands what is inside an SQLite 3 file. And so they actually like watch you make system calls to read and write to the database file, and they ship off like distributed system updates to other replicated copies of your SQLite 3 database. So you've got like a raft style distributed consensus multi-primary database system, but every database is a SQLite file. And it's implemented via a file system that intercepts every read and write system call, which is just amazing. The side effects, the downsides, it means that you're now subject to the CAP theorem again, which you had completely avoided by only having your entire database in one file. And it also means that you have to be comfortable with all of your production reads and writes going through the like user space file system written in Fuse, which like who knows how many bugs that is adding to your database layer. And so I don't know. I haven't actually run any production services on LightFS, but I have talked to people who have said that it has been really fantastic for their specific use cases. So in the end, in the absolute dream SQLite plus LightFS world, you have all of the advantages of SQLite and all of the advantages of this kind of like fancy replicated multi-writer, multi-primary system. Like I haven't built that utopian system yet myself, but it does sound pretty nice, and it does feel more attainable and possible than it ever felt to me personally before, and that is all thanks to SQLite. So thanks, SQLite.